All right, guys, here we go. Section 8.4. We are going to get part one of this today. This will just be the front side of this page, and then the back side of this page will be the second lesson that we'll get to the next time. So today we get our introduction to trig. So this is the very beginning stage of trigonometry, which all comes back to right triangles, just like we've kind of mentioned so far. So I want you to look at this triangle that you see over here. All right, we have three angles, obviously. We have angle S, angle R, angle T. Guys, notice that they use the small letters to represent the side length across from the angle. So if this angle is big S, then the side across from it is little s. So same thing with T. If this angle is big T, then the side across from that would be little t. And then you have this angle is big R, side across from that's little r. Okay, and so just see how those letters are being put together for us. So the big ones are the angles, the little ones are the sides. So from any of these angles, we are going to look at three special ratios taking place here. So we're going to have the sine ratio, the cosine ratio, and the tangent ratio. So these are our three common trig functions that we're going to be using. So the main thing that I want you guys to understand, though, is that when you see those words, sine, cosine, and tangent, understand that they are simply ratios. Remember, a ratio is just where you compare two things, right? And so within a triangle, if I compare two sides together, then it's a ratio, right? So I have a ratio of side lengths. Well, within a triangle, these angles, the size of the angle, is in a big way determined by how long these side lengths are. Because if I were to change one of these side lengths, that's going to affect the size of the angles within this triangle, right? So the first one we're going to take a look at is the sine ratio. So for the sine ratio, what you are comparing would be the opposite leg and the hypotenuse. So if you go back to this triangle here, so angle T is our right angle. So we have two legs. So R and S are the two legs. We can see that T is the hypotenuse. When you look at this from the point of view of, let's just say you were standing here at angle R. So if I'm standing here looking at this triangle, well, that would make S the adjacent leg. Adjacent just means next to, right? So the adjacent leg to angle R would be S. The opposite leg would be R. And the hypotenuse is always the hypotenuse, no matter which angle you're looking at this from. What if you were standing right here at angle S and now looking from here at the triangle? Well, from here, angle R would be the adjacent leg. From here, side S would be the opposite leg. And again, this is always the hypotenuse. So as far as which of these legs is opposite or adjacent depends on which angle you're looking from, right? So when you see that the sine ratio for side R, or angle R, is the opposite leg over the hypotenuse. So if I'm looking right here from angle R, this would be the opposite leg, and this would be the hypotenuse. So if I wanted to see the sine ratio from angle R, it would have to be comparing the opposite leg to the hypotenuse. So R over T. And so that's where you're getting this little ratio right here. The cosine ratio compares the adjacent leg to the hypotenuse. So from angle R, if I wanted to find the cosine ratio, I would compare the adjacent leg, which would be S, to the hypotenuse, which is T. Well, let me just flip those around for a minute. What if I was doing that from S instead of R? So let me go back to the sine ratio for a minute. So what if this just said sine S? Right? So what would be the sine ratio for angle S? Well, for angle S, I want to do the opposite leg and the hypotenuse. So if I was looking from angle S, the opposite leg would be S, and the hypotenuse would be T. So if I were said, what's the sine ratio from angle S, I would want to compare that length over that length. How about the cosine ratio from angle S? So if I wanted to do the cosine ratio, remember cosine does adjacent leg compared to the hypotenuse. So from angle S, if I wanted the cosine ratio, I'd have the adjacent leg, which is r, to the hypotenuse, which is t. So we would write that as r over t. So notice that this changes depending on which angle you're using. Right? They were using angle r, which is why these were the comparisons that were made. So one last one to show you is the tangent ratio. So the tangent ratio compares the opposite leg to the adjacent leg. So if we were going to do that from angle r, so I'm going to compare the opposite leg, which is r, to the adjacent leg, which is s. And that's where they're getting the ratio of r over s. So what would the tangent ratio of angle S be? Remember, if we did opposite over adjacent, so from angle S, the opposite leg would be S. The adjacent leg would be R. It would be S over R. So if I change the angle, if this became angle S, notice that would flip this guy upside down. It would become S over R because I'm looking at it from a different angle. Okay, and so these are the three big ratios that we're going to be working on, right? Pretty much for the rest of this chapter, right? Is sine, cosine, and tangent. They are abbreviated, of course, like we just use the first three letters of each word, right? But that represents sine, that represents cosine, and that represents tangent. So those are our three biggies here. In a little while, you will need to make sure you have access to a calculator that can do those three ratios. So if you look at basic calculator like this, so notice on mine right here it says sine, cosine, and tangent. So you do want to have access to those. Most likely your cell phone probably does that. There's also free ones online that you can use. Like if you go to, I just found a random site. They're all over the place. There's like a ton of them. So I just went to calculator.net, and right here I have a very basic scientific calculator that can do these trig functions. So real simple. So you can always find one of those online if you don't have one handy. Okay. So the first thing we're going to look at before we start using the calculator stuff really is just the basic ratios, right? So we want to get to just the basic comparisons of sine, cosine, and tangent. Now one of the hard parts of this is trying to remember which ratio uses which comparison, right? Because there's like, how do I know if it's opposite leg or hypotenuse or adjacent leg hypotenuse? That gets a little confusing. So there's a very, very common saying that we pronounce as SOHCAHTOA that helps you remember what goes with what, right? So you're gonna keep hearing SOHCAHTOA here. Like every time we try to refer to like trig stuff, we say use SOHCAHTOA, use SOHCAHTOA, so that you remember to use sine, cosine, and tangent. So here's how this works. So the first letter is which trig function you're using. So this one is for sine, that's for cosine, and that's for tangent. The next two letters tell you what is being compared. So notice that the sine compares the opposite leg to the hypotenuse, right? And that's what we saw right here. So the sine compares the opposite leg to the hypotenuse. The cosine compares the adjacent leg to the hypotenuse. So if you wrote it all out, it looks like this. And then tangent compares the opposite leg to the adjacent leg, right? And so here's our tangent ratio. So this is just a nice little short acronym to help you remember what goes with what and how we write these out. So if we wanted to say what is the sine ratio of angle A, so look over here. So here's angle A. So what would our sine ratio be? So we know that sine compares the opposite leg to the hypotenuse. So if I wanted to do that from angle A, the opposite leg would be 5, and the hypotenuse is 13. So the sine ratio from angle A, we would write as 5 over 13. So that is our sine ratio for angle A. They do want you to see these as a fraction and as a decimal. So we could put that in as a decimal and just do 5 divided by 13. Right, so here would be the decimal version of that ratio. To be honest, we're not really going to be using those decimals. We're going to be using those fractions. And so we can write those out if the directions tell us to. But realistically, those really aren't the numbers we're going to be using. We're going to be working with those guys. So let's do the cosine ratio. Notice this is the cosine of angle A. So this is really important because this tells you which angle you should be looking at this from. So I'm doing this from angle A, right? It would change if I was doing it from angle B. That would be a different scenario here. So if I said, what's the cosine ratio of angle A? So go back to this guy. This is really what I want you to be familiar with because this is how you're going to remember it. So the cosine ratio does adjacent leg over the hypotenuse. So from angle A, so here's angle A, we're going to do the adjacent leg, which is 12, over the hypotenuse, which is 13. So that's the cosine ratio for angle A. And then one last one, well, how about the tangent ratio of angle A? So again, we're doing it from this angle. We know that tangent does opposite over adjacent. So from angle A, if I did opposite over adjacent, it's going to be 5 over 12. So those are there to just help you sort of start getting familiar with the ratios for how this would look. All right, so let's practice a couple of these. Make sure you watch this all the way through because the heart of this lesson are going to be these final 3 problems that we do. So you definitely want to make sure you see that. So I want to do one with you, and then what I would like for you to do is try this one on your own, and then maybe like pause the video and try it. So let's just practice a couple of these ratios here. So if we said, what's the sine of angle J? So here's angle J. I would always encourage you guys to write this out. SOHCAHTOA, just to help you remember the order that everything needs to go here. So we know that sine does opposite leg over hypotenuse. So from angle J, the opposite leg is 12, hypotenuse is 20. So it'd just be 12 over 20. You could reduce that, of course. We don't have to, but you certainly could. How about the cosine from angle J? So from angle J, we know that cosine does adjacent over hypotenuse. So from here, my adjacent leg is 16, hypotenuse is 20, so 16 over 20. And then one more of these, we know tangent does opposite leg over the adjacent leg. So from angle J, the opposite leg would be 12, adjacent leg would be 16, so 12 over 16. And that's it. So those are the 3 trig ratios within that triangle. If you want to pause and give these a try, that would be a good thing to do before we hit the final 3 problems. So let's look at the sine ratio from angle L. So now we're working from this guy. So again, we know that sine does opposite leg over hypotenuse. So from angle L, opposite leg would be 32. Hypotenuse is 40. So 32 over 40. The cosine from angle L, remember cosine does the adjacent leg over the hypotenuse. So from here, the adjacent leg would be 24. Hypotenuse is 40. So there's our cosine ratio. Tangent ratio, one last one. Tangent ratio from angle L. Tangent does opposite leg over the adjacent leg. So from here, I'm going to do the opposite leg over the adjacent leg. So 32 over 24. And there we go. So those are the way that we set those up, but really this is just a step in the process because really what all this is used for are going to be these 3 problems right here. So all this information that we just saw was our setup in working towards how we do problems like this. So here's what I want you to see on these guys. Because we've been working with right triangles all chapter, right? And we've already had all these tools for how you find missing pieces of a triangle. So as I look at this, if I said, what is x? Well, what are some of the tools that we've already used to find x? I mean, we've had Pythagorean theorem, we've had 30, 60, 90s, we've had 45, 45, 90s, right? We've already had all these other methods. Why do we need sine, cosine, and tangent? Well, if I look at this triangle, do I have enough information to use Pythagorean theorem? I mean, I really don't, right? I only know one side length. that's not enough to use Pythagorean theorem. Pythagorean theorem, remember that's the a squared plus b squared equals c squared. That guy requires that you know at least two of the sides, right? And so I can't use Pythagorean theorem if I only know one value. So what about the two special right triangles? 30, 60, 90, 45, 45, 90. Well, those are great if you have those angles, but what about an angle like 64? All right, we don't have a special pattern for 64 degrees, right? So this is why we need other tools like sine, cosine, and tangent. So here's what I want to start with. Again, keep this in mind. So here's the first step in this process of solving for x. First thing I got to figure out is which one of those three should I use? Well, here's the angle that I know. I know this is 64 degrees. So everything that I do on this triangle is going to come from this angle. So what are we looking at here? Well, I know the adjacent leg, so I definitely want to use that. I'm trying to find the opposite leg, so I definitely need to make sure he gets involved. So which one of those three trig functions deals with the adjacent leg and the opposite leg? So if you look right here, right, tangent is the one that deals with the opposite and adjacent legs. Both of these two are working with a hypotenuse. And in this problem, I'm not trying to find the hypotenuse, and I don't have any numbers for here either. So we're not involving the hypotenuse. So this one has to be a tangent problem. So here's how we're going to set this up. On the left side of your equation, you need the trig function and the angle. So right now we are working with the tangent of angle 64 degrees. Whenever you do a trig function, you are doing the trig function of an angle. These guys have to go together, right? You can't separate these. So whenever you say sine, cosine, or tangent, it has to be attached to an angle in order to do it. Okay, so we're going to say the tangent of 64 degrees. On the other side of this equation, we need to put in the tangent ratio. So remember, tangent ratio does opposite leg over the adjacent leg. So from here, my opposite leg is x. My adjacent leg is 8. So my tangent ratio is x over 8. That's our setup. So we have to figure out which trig function I should be using. We're going to then use that pattern to set up an equation. And the rest of it is just solving the equation. I just need to get x by itself, right? So in this problem, how would we get x by itself? Well, right now it's doing x divided by 8. So the opposite of that would be to multiply both sides by 8. So I'm going to multiply 8 over to this side. Because that would get x by itself. Once you get x by itself, just put that in your calculator. So as I look at this, guys, one thing that's important is there are two different modes for calculators. One is degrees and one is radians. We are going to only work with degrees, so you always want to make sure your calculator's in degree mode. Otherwise, you won't get the right answer. So all I have to do is type this in. I'm going to hit 8. I'm going to hit my, right here I have my tangent button. So I'm going to hit tangent. And then I'm going to put the angle, which was 64. So I'm just going to type it in the exact same way that I wrote it here and hit enter. And there's my side length. So my value for x would be about 16.4. And that's it. That's how we do this. This is what we use sine, cosine, and tangent for. Right? It's for solving right triangles. So we can find these missing pieces within these guys. So let's try number 4. So here's what I want you to look at. Let's identify the three things that I'm looking at that I have to work with. I got this 29 degrees. I have the adjacent leg. And I have the hypotenuse. So which one of those three trig functions should we be using here? Which one of those deals with an adjacent leg and a hypotenuse? So we see this one right here, right? So the cosine function is the one that deals with the adjacent leg and the hypotenuse. So that's how I know I need to set this up as a cosine function. So we're going to say the cosine of the angle, which is 29 degrees. And then on the other side of that equation, we put the cosine ratio. So from here, cosine does adjacent over hypotenuse. So x over 11. So I'm just going to do the same thing that I did on this one. I'm going to multiply the 11 over to the other side so that I can get x by itself. Because I always want to get x by itself before I put this into my calculator here. So let's do similar to what we did on the last one. I'm just going to type that in exactly the way I see it. 11. And then right here, I'm going to hit my cosine button. And then we put in the angle and hit enter. So in this one, our value for x would be about 9.6. All right, let's see if we can do one last problem here. All right, so I would encourage you to try setting this one up on your own. See if you can figure out which trig function to use, and then see if you can figure out how you would set up the equation with that trig function. As I look at this angle, I can see that I'm working with the opposite leg and the hypotenuse. So as I go back to this setup here, I can see that my sine function is the one that works with an opposite leg and a hypotenuse. So I'm going to set this one up again with a sine function. So I'm going to say the sine of my angle, so sine 41. And then on the other side, I got to put the sine ratio. So sine does opposite over hypotenuse. So this is the one that always trips people up a little bit because now x is on bottom instead of on top. So we got to kind of think some basic algebra here. Remember on the previous two, what did we do with that thing on bottom? We multiplied it over to the other side. I'm still going to do that for this one. I'm still going to take x, the thing on bottom, multiply it over to the other side. So it looks like this. So the only issue now is x isn't by itself yet. I have to take one more step, right? So this is right now, this is x times sine 41. So in order to get x by itself, I have to divide both sides by the sine of 41. So if I do that, it's going to look like this. Now x is by itself. So now I can go to the calculator and type it in exactly the way that I just wrote it on my paper. So I'm going to type in 20 divided by sine 41. And that's it. So our value for x on this problem would be about 30.5. Make sure we round accurately. All right, the 8 pushes my 4 up to a 5. So x is 30.5. And that's it. So that's going to be the main idea for today. And then we'll get into part 2 next time. But guys, as you're doing this assignment, right, I always need to see this kind of work from you, not just a calculator answer. So it's really important that you're doing this setup, right? So show that setup on your way to getting that answer.